Everybody, my name is Pavasha, and in this lecture, we will see what happens when, after neighborship is formed between two routers, how those routers learn about other routers, what exactly happens in a backend, we'll see in this lecture. But so far, what we have learned already is about neighborship, right? Let us revise. So let's suppose we are taking example of R2 and R3. So R2 sent an hello packet to R3. R3 received it. R3 put R2 in the state of init. Similarly, R3 sent an hello packet to R2 and R2 accepted it and put R3 in init state. Now both of these in init state. Now R2 sends in hello packet where in the active neighbor state it contains the router ID of R3. So R3 accepts it, and when it sees that okay, R2 has my router ID in its active neighbor, so now R3 will transit R2 from init to two-way, and similarly this will happen from with R3 also. Now after this, two-way establish. After that, the start states start, where slave and master is being elected, right? After that, from data description packet, exchange is happening, right? As you can see, somebody requests the packet, right? Checking in their own database. Okay, I don't have this information. Now they want this information. They will send the request packet. Then the let's suppose R3 has information about something, and R3 will send to R2 via update packet, and then R2 will acknowledgement acknowledge this is what is happening, right? And eventually they were achieving the full state. That means fully synchronized. That means that if you will go and check the database of every, let's suppose R1, R2, and R3, they all will have the same database, right? So now let's see what is happening beyond, how they are learning about other routers. So here we are using this topology. I have already configured everything that was necessary. And here I have configured loopback address, as you can see via this command. And I made that loopback address also their router ID manually, as you can see here, respectively in R1, R2, and R3. Okay, as you can see here. Now in this lecture, we'll also see the concept of age and sequence number. So for that, let us go and configure our R3. Let me pause it here and I will hit enter. Now let's go and check show IP OSPF database. As you can see here, it has this entry. Now, by virtue of this particular command, what is happening is the corresponding one also gets configured with OSPF. So the hello packet will be sent on to this side and will get the database. So this is why you can see this. Now, if you look at here, it says age, and which is 10 seconds. If you look at it, it is increasing, right? So it is as similar to what we have saw already in switches, right? They used to have entries and they used to get purged. So similarly here also, as the time ages to 36,000, the sequence number, as you can see here, gets incremented. The last bit of it, I'm taking an example of bit, the last value of it gets increased. 8000 blah 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 2 at the end, right? So there are two way in from by which the sequence get incremented. If let's suppose R3 made in another entry. So that another entry will have a different an incremented sequence number. If the age get matured, then also this will get incremented, right? Now let me go and configure R2. Before putting this command, what was happening before is R3 was sending R2 hello packets, but R2 was unable to receive it. Why? Because it was not enabled with OSPF. Now we will enable it. Okay. Now if I'll go and see show IP OSPF database. Okay. Great. Okay. Now you can see that here, if you look at R3, now you can see the different sequence number at as it has generated a new entry, right? Incremented one. Great. Now let us enable the Wireshark and let's understand what is happening beneath. Okay, no problem. Now let us go and configure our this side. Okay. So for that, I will say, okay, let me pause. Okay, now as I enter this, just look at here what's happening, what will happen. As you can see, from R2 to R3, okay, it was intended to R3 only. I know it's a multicast address, but still. And ls update packet went. And then R3 sent an acknowledgement. You remember I told you, right? As they have made the neighborship with each other, now R2 has information about R1 as we have started this OSPF to this site. Now R2 is sending an update packet about this information to R3 and R3 received it, right? And now R3 is sending an acknowledgement packet to R2. This is happening beneath. And if you want to look what information they are sending, this is the information, right? Okay. Now, and let us also see show IP OSPF database. Now, as you can see, the sequence got an increment. It's new sequence, right? What you have saw before, now it is different. Now, if I want to explain what happened when I use use this command was before R2 has an entry about this only, right? R3 only. It was working on this network only. Now, as we enabled OSPF on R2 about a new network, about a new information, R2 is going to regenerate the information with regards to this and then it R2 will send this information to R3 via link state update packet, and then R3 after receiving it will acknowledge it, and as an acknowledgement it will send an acknowledgement packet to our R2. Clear? Great. Now let us go and configure the final R1. Now let's see what will happen. As you can see, look what's happening. So as I've configured OSPF about this network to R1, R2 gets an information about this particular thing. So R2 heavily sends the update to R3, as you can see, and then R3 is acknowledging, right? These are different information that R2 is sending, as you can see here as well, here as well, right? Yes. So now what happened was, first R1 will make R1 made an adjacency or neighborship with R2, right? R2 will ask for R1's LSA, right? And similarly, R1 will also ask, okay, let me put it this way. They made an adjacency, right? Now, R2 will share this information with R3 with the help of link state update packet. And R3 will acknowledge it as we have saw here, right? And what happened before? And also, as it happened for R3, similarly, R1 will request to R2 about the information that R1 doesn't have, which is R3. R2 will send an link state update packet to R1, and when R1 receive it, it sends an acknowledgement packet to R2, right? And the very last and important concept, that is our synchronization. So database. Now, okay, let me put it here also. Let me maximize this. Yes, stop it. Good. Okay. So the final thing is, when we say that a database is synchronized, the way to look at it is that, as I've already told you, the entries should be same everywhere, right? But the main thing is the sequence number should be same in all the databases. Only then we say that, okay, database is fully synchronized. Okay, so router 1, router 2, and router 3. As you can see, 252, right? 252, great. 252, great. So that means that our R1, R2, and R3 are fully synchronized. So this was it for this lecture. I hope you enjoyed. See you in the next one.